Welcome to today's tutorial from the TwinSAFE department. After talking about SLP with manual references a few tutorials ago, today we will have a look at SLP with automatic referencing. My name is Martin Früchte from the Product Management Safety. After giving some basic information and a description of our demo system, I will explain the approach of the automatic referencing. And after the live demonstration, I will give you some additional information, a short outlook of the next two tutorials, and we finish with a Q&A about SLP with automatic referencing. The goal of today's tutorial is the extension of an existing TwinSAFE Motion Wizard SLP project with automatic referencing. So basically, we take an already existing SLP project and we add the feature of automatic referencing. As prerequisites, you need a TwinCAD 3 version greater or equal to 4024.11, a TE9000 version greater or equal to 1211. You need a TwinSAFE firmware version greater or equal to 03 and an AX8000 firmware greater or equal to 0104 with the default module ID active. The start of our tutorial, as already mentioned, is a complete TwinCAD 3 solution with a standard PLC, an EL6910 project, and an AX8000 SLP project. Our demo system consists of an CX for the EtherCAT communication and the standard PLC. We have an EL6910 as master TwinSAFE logic. We have an EL1918 with a connected light barrier, and last but not least, we have an AX8000 in the X2XX in the Safe Motion version. The required safety functionality for today is the configuration and use of SLP with automatic referencing. For the approach of today's tutorial, we have two INI signals for the reference position, and within the EL6910 project and the connected EL1918, we input those INI signals to a FBMON, to a monitor function block, and we accumulate it to a reference signal, and this reference signal we transfer to the AX8000. In order to transfer the signal to the AX8000, we extended the process image from the EL6910 to the AX8000. So in the screenshot you see the outputs of the connection between EL6910 and AX8000, and we added one additional bit for SLP referencing. As you can see in the bit name, today we are using channel B. And of course, we also did the corresponding change at the counterpart. So on the AX8000 input side, we also added that bit information. After the bit is received on the AX8000 side, we combine it with a standard acknowledgement signal, so we can acknowledge the reference position. And last but not least, this information from the EL6910 reference command and the acknowledgement is combined and sent to the internal process image to the bit channel B primary feedback set reference on the AX8000 internal process image. So now it's already time for our live demonstration. We have our TwinCAD 3 solution with the SLP project. In the corresponding group for channel B SLP, we already configured the function block. So when we go to the properties of the function block, we see that all the scaling information is already there. On the EL6910 side, we added the functionality for the INI input and transfer of the INI signal. So you can see the FBMON in the right up corner. And this information is sent to the variable SLP ref channel B. And that information is sent to the AX8000 via the process image. So here you can see that we extended the output process image with the reference bit, and on the AX8000 side, we added a new alias device, a standard alias device for the acknowledgement of the reference position. And the last step we have to do now is to realize the reference functionality. So we add a new network to our TwinSAFE group for SLP, and we add a safe monitor function block. We rename it so we know what we did. We call it SLP ref. The first input mon_in_1 we connect to the command from the EL6910, which in our case we mapped to a global variable list channel B. So here we have our SLP ref command. mon_in_2 is the acknowledgement, the standard input, and the accumulated information is sent to the set reference for channel B information, which is also a global variable in our case. After saving all, the last thing we have to do is to configure our reference functionality. So we go to the alias device of our target system, to the internal safety parameters, and go to the settings for the primary feedback reference for channel B. Now we have to switch over the operation mode to automatic with set reference position enabled. We input our singleton safe position. And we enter our multi-turn safe position, in our case -11. And we can set an allowed speed for the reference position, in our case 2000. And we can define a maximum and minimum range for the multi-turn position. So in our case, we decide to allow a position range from +20 to -20. And that was all for the configuration. Next step is the download of the solution. So we go to our multi-download. We choose our two safety projects. We enter the username and the password. And verify our serial numbers. Start the download. After the download, we verify the CRCs and activate the project. After that, we are ready to test our functionality. So we clear the error list to see if anything new happens. And first step is we want the access in our reference position. So we go to the access to NC configuration. We enable the controller and arrow the existing arrow. And we go straight to our reference position, which is -625 in our case. So now we can go to our safety application. We activate the online view and show online values. And as you can see now in the SLP function block above, you see that the signal primary feedback reference position valid is still false. But we are at our reference position, as you can see in the new function block we added. So now in our case, because it's faster, we go directly to the process image. We force our acknowledgement signal to 1. We immediately see that the reference position valid signal is true in the function block above, and the acknowledgement signal, of course, for our new function block is true. So now we can set it back to 0 and release the force. So now we have a valid position information for the primary feedback. So now we go back to our axis configuration under the motion, and now we start to move the axis back and forth from minus 625 to plus 625 in an idle time of 3. We start the movement and go back to our SLP. And now we can see in the function block above that the multi-turn information is increasing and decreasing. And as soon as it hits minus 11, you see in the new function block that our reference inis are sending the reference command. So everything works fine for the automatic referencing. And that was all for the live demonstration. Some additional information. If you have the use case in your system that you need a manual movement of the axis in power off, so if you need that functionality, you should use automatic referencing. Because if the position info is invalid after startup, if you are using manual referencing, you need a new download of your safety project or at least your safety parameters. With automatic referencing, you need a new referencing process, but you don't have to start a new download process. If you do a manual movement, if the system is running, so the encoder is running and the safety project is running, there's no problem because the position changes are handled and saved correctly. Only in power off state, if you move the axis, you need a new download for the manual referencing. That was all for today's tutorial. Next week we take a look at the safe addresses for AMI and AMP systems, all existing TwinSAFE components, the terminals, the TwinSAFE option for the AX8000, for example, have hardware switches for the addressing. The AMI and AMP don't have any hardware switches for the addressing, though there's a new way to configure the safe addresses, which we will look at next week. And after that, we take a look at AX8000 project with partially different functionalities. We already showed in a past tutorial how to use multi-settings. So you have one safety project for several axes where only several parameters differ, for example, but we will take a look at how you can realize one safety project for several axes, but different functionalities. Thank you a lot for your attention. I hope we will hear again next week with the safe addressing of AMI and AMP.